Authority is a central concept in any networking framework. In coherence, we have a very powerful and flexible authority model that opens up plenty of interesting options. In this video, we're using Unity to demonstrate how it works. To begin, each networked entity in coherence can be owned by only one node at a time. When that happens, we say that the node has authority over the entity. Other nodes on the network also see the entity, but for them, it is considered remote. When you play the game, the inspector of the coherence sink tells you what the current state of the authority on this entity is. The hierarchy also shows it, with an icon next to the entity's name. Full means you have authority. Empty means authority is on another node. Having authority means that the owner can change any of the synced properties, like for instance, the entity's position. Doing so broadcasts the changes to all non-authoritative copies of the entity. If another client tries to modify the value of those properties, they will be reverted back by coherence. For this reason, it is important that if a component is dedicated to changing the value of a synced property, it needs to be acting only when the entity is authoritative. There are several ways to stop a component from acting on remote entities, including some using code. But the simplest one is to ask coherence to disable it for you by choosing so in the config window of that entity on the third tab called Component Actions. If you don't disable these key components, you might see some unwanted behavior, like for instance, being able to control the characters of other players. And now on to the most interesting aspect. In coherence, authority on entities can be shifted around at will. Clients can request authority on entities from each other, and, if granted, they become the new owner of that entity. This is a powerful paradigm shift that opens a lot of possibilities. For instance, in this demo, the crates being carried by the little characters are a physical object that is authoritative on different clients at different times, depending on who has bumped into it or who picked it up last. We built an authority visualization view in this demo. Blue means that, from the perspective of this client, the entity is authoritative, and orange means that it's remote. Whenever a client needs to interact with a crate entity, they request authority. If the crate is not being carried by another player, the request will be fulfilled, and the authority immediately shifts to the player that requested it. This allows creating some pretty reactive distributed physics by simulating each crate on the client to which it matters the most, that is, the one that is currently interacting with it. All the other clients who have no authority on the crate will see it as a kinematic rigid body. And by the way, the shift to kinematic can also be automated in the Component Actions tab of the config window. There are different modes to how authority changes can happen. You can choose one using the appropriate option on the coherence sink. With Steel, authority requests automatically succeed. With Request, the owner has a chance to respond to a request and deny it if they so desire. Not transferable will make all authority requests fail. Authority requests, for instance, can be used to create a system of exclusive interactivity with networked objects. Sorry, it's busy. There is a special state for when nobody has authority over an entity. We say that that entity is orphaned. If any script has been set to disable, it will be disabled on every instance of that entity on every client. You can think of an orphaned entity as an entity that everyone sees as remote. If an entity is set to persist, when their owner disconnects, they will remain on the replication server as an orphan. Any connected client can then adopt it at any time. In fact, we even offer a checkbox to automate this, no code required. What is usually referred to as RPCs in other frameworks, in coherence we call network commands. However, they work slightly differently. There is no such a concept of a command that executes only on the server or only on the client. So if you're coming from another networking framework, this distinction is quite fundamental to grasp. In coherence, commands are invoked using a coherence sink as a channel of communication, and you can invoke commands also on entities that you're not the authority of. To mark a method as a command, you can do it from the second tab of the configuration window. When sending a command from code, you can choose who the destination is, and depending on the authority state of that entity, the command will travel to one or more clients. Let's see an example. Suppose we have a game with player-controlled characters. Logically, each of these entities is owned by the player that instantiated it. So at each moment, each client sees their own character, which is authoritative to them, plus all of the others, which are all remote. If we send a command on our own character and we choose message target authority only, we are effectively sending it to the same instance. If we target another character though, the message will be delivered to the client that currently holds their authority. If we use message target other, regardless of which entity we target and their authority state, the message will be propagated to all other clients and delivered to the same network entity, but not to the one on the client who sent the command. If we choose message target.all, then again, the message will be delivered to all copies of that network entity on all clients, including the one where the command originated. Choosing the right coherence sink and the right message target is fundamental, and it depends on the effect one is trying to achieve. Another big difference in how coherence manages authority is that all of the rules we talked about so far apply equally to both regular clients, human players playing the game, and instances of the game running in the cloud, usually referred to as servers, and which in coherence we call simulators. An entity can be owned by either a client or a simulator, and only that node has the authority to change its synced properties. Any script that might be looking to change those properties will need to be disabled on other clients or other simulators, just like we saw before. Similarly, messages sent with authority only will be delivered to its owner regardless of whether the authority of that entity sits on a client or a simulator. This connects to what we mentioned before with regards to how network commands work. A command is not inherently a client command or a server command, but it will travel to whoever has the authority at any given time. Authority over an entity can also be shifted around between clients and simulators, which can perform authority requests to each other. This allows client to disconnect and concede authority on persistent entities to a never-sleeping simulator, and on reconnection, they can take it back. However, if an entity is marked to be server-side, only a simulator can have authority over it. If a client were to instantiate such an entity and a simulator is connected, authority on that entity will be immediately taken away from the client. Authority can also be passed between several simulators to balance load between them. Because authority transfers are fast, they can happen at any point during the game. You just need to choose the logic of when and how many entities are distributed to each simulator. In conclusion, we have seen how authority is a central concept in coherence. We learned how to stop thinking of a network entity as being something that is controlled by either a client or a server, and saw how authority looks more like a token that can be passed around. Once you have familiarized yourself with how authority works in coherence, you will find it's a system that is logical, flexible, and very powerful. There is more to authority than we haven't covered here, like server authoritative scenarios, and the distinction between state authority and input authority, but that is for another time. Check the description below for direct links to the topics covered and to download the sample projects used in this video.